Hey, so this time we are doing Desmos Unit 5, Lesson 8 practice. Or if you're online, it should say 7.5.8. Let's get to it. We're going to start off with some little expressions where they want us to figure out the value of the variable. So the first one's 3 times -4 equals a. So it's just what is 3 times -4? Hopefully you're starting to get pretty good at this, but let me remind you of this triangle thing. So you got this triangle. You put negative symbols down here at the bottom corners, and then you put a plus symbol or positive symbol up there at the top. And if you ever forget, like positive times a positive, well, that one I hope you don't forget, but negative times a negative, what is that? Positive times a negative, what is that? The trick is just cover the two symbols that you're working with, and the one that you can still see is your answer. So for here, we're doing +3, so I'm going to cover the positive symbol, times -4. I can still see a negative symbol, so that reminds me that my answer is negative, and 3 times 4 is 12. Now here, we got b times -3 equals -12. Now that might be kind of easy for some people, a little bit harder for others. I'm going to show you the way that I would like for you to think about it. Multiplication and division work in reverse of each other, right? So if I give you something really easy, like 2 times 3 equals 6. Now I want you to think about what happens if you reverse this question. If you take the 6 and divide it by 3, you're going to get the 2, right? And if you take the 6 and divide it by the 2, you're going to get the 3. So you can take this number here in this position and divide it by either of these two numbers, and you'll get the other one. So applying that to here, if we take -12 and divide it by -3, we'll get whatever b should have been. So let's go -12 divided by -3. Now this triangle up here works for multiplication or division. Multiplication and division follow the exact same rules when it comes to like whether the answer comes out positive or negative. They're the exact same rules every time. So if we're doing a negative divided by a negative, cover up your negatives. I could still see that positive symbol. We've got -12 divided by -3 is +4. So b equals +4. I guess I should have written a equals -12 there, but whatever. Okay, so here we got 12 times something equals +12. Okay, so I feel like this one we could probably figure out without having to like do this trick. We could do it exactly like we did this one. We get the right answer, but let's think about it. We don't want the number itself to change, right? We want, here's a 12 and here's a 12. The only thing we want is to switch it from negative to positive. And there's only one number that does that for us. There's only one number that does that for us. It's a 1, right? Because 1 is that special number that when you times it by any number, it just stays the same. But in this case, we need its friend -1. That's what's going to change that. -12 times -1. Well, we wind up with a negative times a negative, which gives us a positive. But 12 times 1 is 12. So this time c equals -1. All right, I'm going to let you figure out this last one. This one, I would recommend you use the trick of take the -12, divide it by the 24. You might wind up putting that into a calculator to get a decimal answer, or if you can put it into a fraction, that'd be great too. But just be careful whether that answer should be positive or negative. Let's move on. So next we got this whole row of fractions to deal with, right? But each fraction actually has all the same numbers in them. It's always a 15 over a 12. We just have different positions of negative signs and different numbers of negative signs in each one. So in determining the values, all of the numerical values of these are going to be the same. It's just our job to figure out whether they're positive or negative. And so all of these, let's figure out just the numerical values first. If you punch 15 divided by 12, remember a fraction bar means division. Where I just put that orange line, that's division. -15 divided by 12. This is 15 divided by -12. This is -15 divided by -12. Think of fraction bars as division. If you put 15 divided by 12 into a calculator, you're going to get the value 1.25. If you're like me and you like fractions better, Then let's do a little side work, simplify this fraction, and then you can enter your answer as the decimal or the fraction. It's okay either way. Let's see, I'm gonna grab piece of paper from previous one of these videos I did. So it's 15 over 12, right? We can simplify this fraction. I noticed that 3 goes into 15 and 3 also goes into 12. So let me divide the top by 3 and the bottom by 3. And I'm going to get 15 divided by 3 is 5. 12 divided by 3 is 4. This is the same number, 5/4 and 1.25. That decimal we already wrote there is the same thing. So for all of your answers, you can use either one of these. But we got to be really careful about whether it's positive or negative. Just remember the rules, what's built into this triangle here. If you got positive divided by positive, it's positive. If you got positive divided by negative, it's negative. If you got negative divided by positive, that's negative. And if you got negative divided by negative, those two negatives cancel each other out, like we like to say, and that one's positive. So here we have negative divided by positive. Negative divided by positive. I can still see a negative symbol there. That's my reminder that this one should be negative. So you can have negative 1.25 or you can have negative 5/4 as your answer here. Next one, we have a positive divided by negative. That's going to turn out negative. So you could have negative 1.25 or negative 5/4 as your answer. The next one, we have negative 15 divided by negative 12. This is a negative divided by a negative, which results in a positive. So you could have your answer as positive 1.25 or positive 5/4. So I'm kind of switching back and forth between decimal and fraction. This last one here only has one negative symbol and it's in the front. This time, the negative symbol isn't really like on the 15 and it's not really on the 12. It's actually on the whole number itself. I want you to think of this as this is the number 15/12 or 15 divided by 12, but the negative version of it. And so this number is for sure negative. So again, you could have your answer as negative 1.25 or negative 5/4. When you're putting a negative symbol on a fraction, like I'll use 5/4, I guess, as my example. If you have the negative symbol up at the top by the 5, and it's just one negative symbol, this is a negative number. If you have the negative symbol just down below by the 4, but it's just one negative symbol, that's a negative number. And if you have it out in the front, like in the center, that's also a negative number. All of these are negative. But if you double up on the negative symbols, if you go -5 over -4, those two negatives are going to cancel each other out and create a positive. And then obviously, if you don't have any negative symbols at all, then of course we know that's positive, right? And so these two are positive. Very important that you know that. So program that one in. Moving on. Determine the value of x that makes each equation true. We're essentially solving equations here. The trick to solving equations that we haven't really got to yet, you'll be really good at this by the end of the school year if I've got anything to say about it. It's just do the opposite of what you see. If the number you're looking for is part of a division, then do some multiplication to figure out what it needs to be. And if the number you're looking for is part of a multiplication, then do some division. I hope I didn't just say the same thing twice. I meant to say one and then the other. I hope you get what I'm saying. Here, look, I'll show you. This says -3 times some unknown number equals 6.3. Okay, so we're trying to figure out what goes in this multiplication. Let's work backwards with division. It's the same thing I was talking about up here with the 2 times 3 equals 6. So 6 divided by 3 equals 2. 6 divided by 2 equals 3. 6.3 divided by -3 is going to get us what goes in that x. All right, I'll let you figure out what that is. Your answer should be negative. I'll let you punch it into a calculator or whatever to get the answer. Now this one, it says the number we're looking for divided by 3 equals -12. Okay, so let's reverse the question. If we're trying to figure out some piece of a division, let's multiply through to see what it needs to be. whatever 3 times negative 12 is, that's going to get us our answer for x. Okay, so I want you to use the same procedures for these two. Number 2.3 is the same setup as 2.1. So just put the pieces together the same way I did, right? This one, you're going to have a negative divided by a negative. So I think that answer is positive. And then this one is set up the same as 2.2. So follow the steps that I did for 2.2 to work your way through 2.4. And that one, I think you're going to wind up with a negative times a negative. So you should probably wind up with a positive answer for that one. All right, so this next part about this machine drilling holes for a well or whatever it is, I'll tell you that in several school years, the test that comes up at the end of this unit has a question that is essentially this exact question, just with the numbers changed. So you definitely want to make sure you're able to do this question because it might pop back up on you whenever test time comes around, which is, if we're already on lesson 8, it's probably pretty close. It says a machine that drills holes for wells is drilled to a depth of negative 72 feet in 1 day, 24 hours. It's a 24-hour operation we got going on. So how much did the depth change each hour? So we got to be able to find a rate, right? We've learned how to do rates. You take one quantity and divide it by the other. That's essentially y divided by x or whatever. So if we do negative 72 change in depth divided by 24 hours, then we should be able to see its change every hour. And it says to make sure to show whether that change is positive or negative. This drill is drilling downwards, so its rate should be expressed as a negative in this case. I hope you get a negative something as your answer here. Okay, and now it says if the machine drilled at a constant rate, so let's say whatever your answer is here, it's always going exactly that rate. It's not like going faster, sometimes slower, some other times. Then what was the depth after 15 hours? So what you got to do here is take this answer that you got here that I don't want to give you. Hopefully you got it. Put it right here in this box. And then you're going to multiply it by 15 hours to see how far it went in 15 hours. Now, your answer here should be negative. Whatever you got in this box should be negative. You're multiplying it by a positive. So you should wind up with a negative answer because this is going to show some negative position that the drill has reached at this point. All right, and then lastly, it says, at this rate, how many hours will it take until the drill reaches its final depth of negative 132 feet? So again, you're going to need this number. You're going to take that negative 132 depth and then divide it by its rate, and that's going to tell you how many hours it took to achieve that depth. So I want you to divide by that same number that you've been working with this whole time. And like I've been saying, that number should be negative. So you should have a negative divided by a negative set up on this one, which is going to result in a positive, which makes sense because this one's talking about time. Like how much time did it take the drill to drill down to that depth? And we're not doing any weird negative time rewind stuff in this one. So you should wind up with a positive answer on this one. All right, let's move on. It says 30 plus negative 30 equals 0. Those are additive inverses of each other. Write a different equation with two numbers whose sum equals 0. Literally any additive inverses, any number plus its opposite. I like 49. 49 plus negative 49 equals 0. Okay, now write an equation with three numbers whose sum equals 0. So here you can't really use additive inverses because, well, I suppose you could if you threw a 0 in there, but that'd be kind of cheating. So what if you did this? What if you used 49 again? No, let's make our lives easier. What if you use 10? Now you know that 10 plus negative 10 equals 0. But if you throw a negative 10 in there, then you're already at 0 and you need a third number, which, like I said, you could use 0, but let's be more clever. What if you put two numbers here? that added up to negative 10, right? Like this plus this make negative 10, so that when you add them to the positive 10, you get 0. See if you can do that. All right, and then write an equation with 4 numbers whose sum equals 0, none of which are opposites. And one example of opposites is negative 30 and 30. So 4 different numbers, no zeros, no opposites. All right, so didn't say they have to be super big numbers, so we could do something kind of easy. What if we did, like, I'm going to set it up like this: blank plus blank plus blank plus blank equals 0. What if I start with like a 5, a 2, and a 1? What do those all add up to? You can figure out what those add up to, right? What's 5 plus 2 plus 1? Now, whatever the opposite of that is, you can put right here, right? So like, this isn't the right answer. Let's say these all added up to 12. They don't, right? 5 plus 2 plus 1 is not 12. But if they did add it up to 12, then you could just toss a negative 12 right here, and the whole thing would add up to 0. So figure out what they do add up to, throw the opposite in that last spot, you're good to go. Write an equation using 4 numbers that multiply to 0, none of which are opposites. This is actually extremely easy. 0 times any number is 0, right? Billion times 0 is 0. Negative 84 times 0 is 0. So just use that fact. Just throw a 0 in there. You'll be all right. All right, last one. Here is a number pyramid puzzle. Fill in the blanks so that each number is the product of the 2 numbers directly beneath it. Okay, so this is similar to the Explorer from the previous assignment. So whatever is here came from the 2 numbers below it multiplied. 12 times negative 4 is negative 48. And so you could figure out this one here. Negative 4 times a half is negative 2. All right, now you got both of these numbers, so you could figure out this one. And you got both of these numbers, so you could figure out this one. And it'll probably be like, there'll be some way where you can move your way all the way up to the top, but then you'll need to come back down using division in order to, like, probably in order to figure out this one in the end, if I had to guess. I don't know, maybe there's a different way to do it, but don't leave it blank. At least try it, even if you can't solve it. All right.